Just a quick little video about how a few different types of motors work. This particular one has 4 gigantic coils here, and these coils act like magnets when you have current running through the coils, all right? So what will happen is when we run current through this, these 2 coils, when I run a steady current through them, will just be like steady little permanent magnets, these 2 coils. So this machine would work the same if I just set 2 permanent magnets here instead of coils, right? This part is a little bit more complex. So what will happen is when we run current through these 2 coils, because we're going to run current through everything, this magnet will be attracted to this particular magnet. So it will swing over, right? Now, right when it gets here, if we don't do anything else, it'll just attract, and so then the motor would just kind of start running, and then it would just kind of jostle into place like this and wouldn't be a very good motor. So what we want to happen is when we run the current through these coils, we want it to attract, but then the moment it gets here, we're going to switch the current in this coil so that it then repels, right, and gets pushed away, wanting to come toward the other coil. So the way this motor works, basically this coil says, oh, I want to be there. Oh, now I don't. This one comes around, now I want to be there, now I want to be there, and it will just keep switching the current in this way. Now where the real clever part is and where the switching happens is right here. So there's these little plates here that are called the brushes on this type of a motor, and what it's going to do is deliver current to this guy to make it attract over. You can see this little plate here right when it gets to this position. You switch from this electrode to this one, which actually makes the current run the other way in this coil, that then makes it repel when it gets there, okay? So you'll notice if I first turn this on with just a tiny bit of current running in this thing, you'll see it attract over, but then get pushed away as it passes by. So let's kind of give it a cheater start. There it goes, right? So what I'm going to do now is turn up just a little bit more current, and let's get it going. So right now I can feel these coils are being attracted here, but then you'll see once the current switches, it'll repel away. All right, so let's try to get it going. What's beautiful about this is the timing between attracting the coil and repelling the coil. It actually happens with just the right timing automatically, because the timing of the switch is set by this clever little mechanism to happen right when one coil is pointed at another. Now, of course, we should make this go faster just because we can. So I'm going to just turn up. I'm going to feed more current into the motor. All right, now I'll cut the power. So fun little simple motor. Again, the idea being that you have these coils attract each other, and then once they get into this position, you switch the direction of current in this coil to make them repel. That's actually happening on both sides. I've just been fixating on this side. And so you basically have an attraction, repulsion, like that, with just the right timing ensured by this connection up here. All right, so we saw in looking at the last motor that putting current through a coil can make the coil act like a little bitty magnet. So the principle of operation behind this motor that I built is that you run current through all the coils, and you have it set so that, say, this coil that I'm pointing to is attracted to the magnet. Well, right when it gets there, you switch the direction of current so that then the next coil wants to get there. And so the principle of operation with this motor is just each coil goes, no, I want to be there, no, I want to be there, no, I want to be there. Well, since there's 8 coils on this drum, the current actually has to switch directions, well, 8 times every time this thing rotates around once. The entire drum rotates around once. The switching happens here because of these electrodes. So every time as this thing turns, every time the electrical contact slides from one plate to another, that actually switches the direction of current. And that's what allows me to make the switching happen with just the right timing to keep pushing this thing. All right, well, so let's see this thing go. What I'm going to do is deliver the power to the electrodes by just touching with these 2 wires, and let's see what we get. Again, the neat thing is this thing is getting pushed with each rotation. It actually gets 8 little pushes because every time one of those coils gets near the magnet at the bottom, it gets a little push. So this motor is incredibly similar, although instead of being one that was MacGyvered together by me, this one is just taken out of a drill. But the principle is actually the same. You can see these coils in here, and what's going to happen is we'll run current through it so that a particular part of a coil will be attracted to this magnet. And then right when that coil gets there, we'll switch the direction of the current so it gets pushed away. Over here is are the plates where we deliver the power. And so you'll see I'll do that, and yeah, this one's really built to hum. So I'm just gonna put on the same voltage that I was putting on with mine, and you'll see this drill motor take off. So 3, 2, 1, here we go. And that, my friends, that's the basics behind how DC motors work.